supercomputer in general are meant to address today's problems, and they are big problems. We have issues of lots of data and what to do with it. We have problems that typically cannot be solved by one individual, but pieces are solved in one way by somebody, in another way by somebody else. But people don't talk. So supercomputers allow us to take what seems to be unrelated pieces of information and put them together.
Well, many questions cannot be answered easily by experiment alone, because we may lack the ability to do a controlled experiment, or we may lack the time needed to carry out an experiment in order to act on it today, for instance, simulating centuries of climate. Many experiments actually should be guided in their design, if possible, by simulations. For example, closer to the laboratory, you may have 100 compounds that are suggested to you from the periodic table that would have a suitable band gap for photovoltaic devices. But are you going to test more than 2 or 3 of them? No, you have to reduce the field by simulations if possible. Or you may, in drug design, want to try to deduce by simulations what compounds will bind to a certain cell. So these are examples of how simulation can lead experiment. It can never replace experiment, which holds the ground truth, but it can help us to use experimentation efficiently. From an industrial and strategic perspective to a country, to outcompute is to outcompete. The more powerful a computer we have, for instance, the more memory, the greater fidelity and accuracy we can build into our models. And the faster the computer is, the quicker we can get turnaround on various things that we want to simulate, relating to the speeds and feeds of the processor and the tight coupling of the network. So more accurate simulations finished faster is the real importance of high-performance computing. And all countries that are serious about industrial or strategic leadership in order to compete with other countries that have powerful supercomputers eventually find the need to invest in this way.
KAUST is a special environment. We are small, but we are very intense in what we do. We select very carefully our problems, and as a result, we are in certain fields of science and engineering. Then at KAUST, we chose to do both fundamental research and more applied research, typically in our research centers. And these centers typically focus on very much the problem of today. Our new supercomputer, Shaheen XC40, is rather unique in a university environment. Usually you do not find a computer with this power in a single university, especially not one as small and compact as ours. Small in size, but very big in ambition. Now, having this supercomputer, we can solve problems on a large scale. And therefore, I think it is important for us to provide access to this resource to other universities, industry, in Saudi Arabia, of course, but also in other places in the world, to look at problems, for example, that are global, solutions of energy, how to best use, for example, solar power, how to make use of the resources that are underground, both mineral resources and oil resources, how to manage the water, how to use our ability to predict better, not perfectly yet, the climate, and so on. So I think this facility, though it will be located in KAUST, will be open to many, many others to work with us. So at KAUST, we look very much at having state-of-the-art instrumentation in order to do state-of-the-art research. This means that this supercomputer, for example, is only one tool. We have many, many other tools. We have, for example, a core laboratory which has hundreds of millions worth of equipment. And believe me, this equipment is used every day. Many, many pieces of equipment run 24/7. And this equipment allows us to do microscopy on the scale of an atom. It allows us to study very quickly the genome of a plant, or human genome for that matter. It allows us to analyze contaminants in water very, very quickly, and so on. So all of this is key to the operation of KAUST. To operate at a high level, you need to have high-level tools. And this new supercomputer is one of those tools.